Good afternoon, everybody. I'm Lindsay Harrell. I am the president of the Hilton Head Island Concours d'Elegance and Motoring Festival. And I want to welcome everybody here with us today to our third event on the Driving Young America Boulevard powered by Castrol virtual series. We formed a partnership last year with both Castrol and Michelin to start a Driving Young America Boulevard presence at our event last fall. And really the thought process behind that was to provide a venue at the event where students and their parents could go and explore potential career opportunities, scholarship opportunities, and really start to inspire the next generation of our automotive workforce and of our collectors and enthusiasts. So we started this virtual series this year in light of COVID as kind of an extension of that from our event last year. And I know we're all extremely anxious to get into 2021 when we can plan and bring back the DYA Boulevard physically to our event again next year. So today's event is an industry insiders event, and we've got the best of the best here with us today from Castrol and Michelin to give us a little insight on motor oil and tires and what's new in those industries. First, I'd like to welcome Derek Guinane from BP Castrol. Derek has been with Castrol for nearly 30 years after earning a BS of Chemical Engineering and Masters of Applied Chemistry from the New Jersey Institute of Technology. Derek currently serves as a Senior Technical Support Technologist and provides product technology and claim support across the Castrol passenger car and motorcycle product lines. Derek, welcome.
So, a brief agenda, probably about 15, 20-minute presentation. We'll talk about, what Castrol is, what the Castrol brand is, what's unique about our technology. And then we'll go into the heart of, what's in motor oil, how it functions, what does it have to do in an engine. When you put together, you see a picture there of like a couple of our chemists working in the lab, what they're actually doing, what ingredients they're putting in, why the different ingredients are put in there, what their function is in the motor oil. We'll talk about some of the testing that goes into motor oil, and really how it's protecting your engine, what it's doing in there, how it's preventing all the bad things that can happen in an engine from happening in your engine, and why you want to use a quality motor oil. We'll also talk a little bit about viscosity and the different motor oil grades. You hear these, 5W20, 10W30. What does that all mean? So we'll talk a little bit about that. We'll go through some basic consumer information to say, like, what is a good motor oil? What should I be using in my car? And then, if you go into a store and you look at a bottle of motor oil, you say, what's all this stuff on here? We're guilty as anybody of having a lot of stuff on the back of our label, but look for the important things that you need to know for your vehicle. At the end, we're actually going to move it to after the second presentation from Michelin, we're going to go to questions at the end of that time. But, if you have questions, please write them in the chat box, and we'll answer any questions at the end as well. So with that, Lindsay, we'll kick it off. If you can, next slide, thanks. So just briefly about Castrol. So people, if people aren't familiar with Castrol, Castrol has been a brand that's been around for over 100 years. It was first founded in 1899, as it says here, created by Charles Wakefield. And really what the key thing to highlight is for years, Castrol actually was bought by BP around 2000. But for 120 years, we've been making lubricants. And what the Castrol brand is known for a number of things, but in vehicles, and that includes passenger cars, trucks, boats, airplanes, anything like that, anything that has a moving engine. We have been known as the leader out there, the technology leader out there in protecting these engines. And the engines have gotten more and more powerful over the years, and Castrol has been there to protect them. And we have a number of land, sea, and air records, as it mentions on the slide here. Just a couple of things, to highlight that we're into now. We do have a car that we run in NASCAR. We won the Indy 5, the vehicle where we've lubricated for the Indy 500 has won a number of times for us. We've have, as it says, a number of land speed records, aviation records, marine records, a number of those things. So we're known for being the oil in a lot of very powerful engines. And this, as it says, the success of our company has always been the fact that we've put technology first. We've always wanted to make the best oil out there. Nothing bad about any of our competition that's out there, but we think we are the technology leader in things out there. And as we said there, it's gained us the reputation over the years with all this work that we've done with all these high-tech engines and all these research and development we've done over the years. We feel we are the technology leader. So Lindsay, you can go next slide. And, how do we say that? Well, what makes us different? This is a picture actually as it leads into our laboratory. Our laboratory is in New Jersey. Unfortunately not there right now, but we have a number of people who are in the lab. But leading in there, there's a number of patents leading into the laboratory. And how we're different, it sort of is highlighted by those patents. So when we talk about motor oil in a bit, we're going to talk about there's base oils and there's additives. So for years, we've made actually our own additives. So when you make a motor oil, you take your base oil and you take your additive. The additive typically comes from 4 different companies that are out there. There's and I'll talk about them in a bit. And that's what all the other oil companies that are out there do. They purchase an additive package and they put it with base oil. Depending on the degree of how good the additives in the base oil are, will determine the quality of the oil. Where we're different is for over 30 years, we're the only ones who have made actually our own additives. So we take the stuff that we make that we've tested for years and years and known that we have the best things going on with it. And then we also add in the best additives from the additive companies, and we combine that and make a custom-made additive package. I think I'm getting some background.
Because you're going to run everything from here. I'm not.
Hold on 1 second.
I'm just going to get you started, and then you're just going to use mine for the whole.
Lindsay, we have some background noise from.
Yes, bear with me 1 second.
Yeah.
Okay, I think you're good now, Derek.
Okay, thank you.
Apologies.
So like I was saying, we use our own technology, which is patented. It's only used by us. And we take that and we take what the additive companies have and we combine it with that. So we really make sort of like a custom made, if you think of a custom made suit, or if you made like something homemade versus buying in a store, that's where it's different. It's more quality put into it. And we have that with an additive that can, we talk about the different things that can happen in an engine. We're trying to prevent sludge. We have things that work really well on preventing sludge. We also have this titanium chemistry and this phosphorus replacement technology. It better protects the engine and makes your engine run longer and for more durability in it. And I think I covered the rest of it on there. So Lindsay, we can go next slide. So first off, just to talk about what does a motor oil do? So a motor oil has a lot of different functions. Even though it's something it's other than gasoline, or whatever you're putting into your vehicle, the only other thing you really change really often is motor oil. You change it, and depending on what your owner's manual calls for, you change it on that duration of whether it's a certain amount of time or a certain amount of miles that you put on it. But what it's really doing is there's a lot of different functions. A motor oil is really like the lifeblood of your engine. It circulates around the engine. And it does a number of different things. There's a lot of different metal parts in your engine, and if you've ever tried to rub 2 metal parts together, they'll start scraping together. If you think of rubbing your hands together, you'll feel like heat being generated. Same thing happens in an engine. And when it happens, 2 metal surfaces come in contact, what happens, it doesn't just you don't generate heat like you generate heat like you do on your hands, but you also start scraping metal surfaces. So you start causing wear. And the engines are designed to very, very tight tolerances. So once you start scraping metal, that's a problem where you're going to have the metal fall out, and then you're not going to have quite the sealing that had happened is designed for the engine, and you're going to have that heat generation. So motor oil does 2 things. It cools the engine down, and it creates a very thin film that prevents the metal surfaces from coming in contact with each other. Also, as gasoline and all the other byproducts of things that are going on in your engine happen, things like sludge and deposits can form in your engine. They can form on your pistons. They can form on different areas. They can form in your oil pan or screens and things like that. Filters. The job of the oil is to go around and collect all these things before they plate out, or if you want to think of it or falling out onto your engine. So you want to prevent that from happening. So a good lubricant, if you look at that bottom picture there, you see that's a very clean looking engine. You want to prevent sludge buildup or anything like that happening in your engine. There's a couple other things it highlights there, lubricating surfaces, maintaining cleanliness, cooling the engine components, sealing combustion gases, preventing wear, and making your engine start easily. So you want to make sure you're using the right oil so it's actually starting properly. Next slide, please. So now we're going to talk a little bit about what goes into motor oil. And this is really the heart of what we want to talk about today, of what goes into motor oil. So it's, if you think of a recipe or you're putting something together, as a ballpark, it's about 80% base oil, and the base oil comes from crude in the ground. It gets refined, it gets sent to a refinery, and it takes out some of the impurities, things like sulfur, waxy type materials, all that stuff. And the more it's refined, the better the oil is. And base oil is broken down into things called groups. So there's, group 1 is the least refined oil. Group 2, it goes to group 3. Group 3 is where you're getting into what we call synthetics, and then there's a couple other groups after that. There's a PAO, and then there's another sort of catch-all one. If you're thinking the stuff coming from the ground, the crude oil 1, 2, and 3, the 3 is the best, like I said. Now, there's a misnomer in the industry where you think like, if it's a synthetic, it has to be good. So base oil is a key part of it, and the group 3 oil is definitely going to be better in properties than a group 1. But that's not to say that synthetic oil has to be better, because it also goes into the fact of the additives that you put into the motor oil. So, and that's really the heart of, what goes into making a good engine oil. So, as it mentions there, about 10% ballpark, and it all depends on the grade of the oil, is what we call a viscosity modifier. And that changes how the oil flows at different temperatures. But then there's a number of other additives that go into it. And as we talk about, I mentioned we have patented things on dispersants. If you see not the bottom picture, but the one to the right above it, you see an engine that it contains a lot of sludge in it. And sludge is a buildup that happens. You need to put something called a dispersant in there. And basically what that's doing is just simply keeping the dirt or all the bad things that are happening in your engine in solution. You also use detergents, and they go around and they clean things like, the pistons and all these other areas to make sure that, again, metal surfaces are being kept clean. Again, where Castrol is unique is we make our own dispersants and detergents and use them in conjunction with the additive companies at packages. You also have things like anti-wear agents, where when you have your camshaft rotating around and it's moving toward the piston, moving toward the valves, that's letting the pistons go up and down. What you want to do there is you want to, that's a very thin layer of contact. You want to make sure that you have oil so there's not metal to metal contact. Also, oil has, we're going to talk about viscosity in a minute. You want to keep the oil from thickening too much. So you have to use antioxidants in it. And then you also want to keep it flowing at low temperatures. So you use things like pour point depressants. Then there's also things called friction modifiers and anti-foam agents. So that whole, other than the first 2 bullets there, the rest of them go into what we call the additive package. And that's really the key to motor oil. So the better additives that you put in there, the better it's going to protect from all these different things that can happen in an engine. So, and we actually have industry tests that make sure that's preventing these things from happening. So, to keep things on time, we'll move forward. So, real simple science definition of viscosity. The technical description of viscosity is resistance to flow. It's of a liquid, of a fluid material. Viscosity is very temperature dependent. So at low temperatures, it's not going to move as quickly. And as you heat something up, it's going to move much quicker. You've probably seen this, a simple example I use sometimes is, well, my wife makes pancakes at home. If we have maple syrup in the fridge and it's cold, you stick it in a little thing of water, hot water, it'll heat up and you pour it over your pancakes. Same type of thing with motor oil. If you go to start your car on a cold day, it really doesn't want to move that quickly. But as it heats up, as you start it, you got to have the engine crank. And then once it cranks, it'll heat up with the engine heating up and it'll flow through quicker. But you need to have that protection at low temperatures and at high temperatures. So go to the next slide. So how motor oil is classified is by something called, it's a standard known as SAE J300. So SAE is the Society of Automotive Engineers. And if you look up if you look up a simple internet search, you'll find what the spec talks about. But real simply, if you take an example of a 10W30, which is popular, probably about 20 years ago, is probably the most popular grade. The numbers represent different things. The 10 part of it represents the flow of an oil at low temperatures. So there's a whole specification, and they cool it down to very low temperatures. We're talking, minus 25, minus 30, minus 35 degrees. Not relevant in a lot of areas, but here in New Jersey, as we get colder in the winter, it certainly can get down below 0. So you want to make sure you have an oil that's going to flow. So as you look at a grade of motor oil and you look at the numbers, the W that's next to it, the W actually stands for winter. A lot of people think it stands for weight, but it actually stands for winter. So that's related to how it's going to flow at low temperatures. The easy thing to remember about any of the measurements is the higher the number, the thicker the oil is going to be, and the lower the number, the thinner it's going to be. So when we talk about a 0W20, 0 doesn't mean nothing. It actually relates to the temperature that the testing is run to see if it's going to flow at low temperatures. On the other side of so there's a dash after the W, then there's a number, say it's 30 here in this 10W30 example. That relates to how the oil is going to flow at higher temperatures. It's actually similar to what the temperature the engine is as the oil is flowing through the engine at operating temperatures. And same principle. So if you had like, a 10W50, it would flow exactly the same at low temperatures, but at high temperatures, a 10W50 would be a lot thicker than a 10W30. Where that becomes important is, as I mentioned years ago, about 20 years ago or so, let's say, 10W30 is probably the most popular grade. As time's gone on, engines have gotten smaller and smaller. And what I mean by that is the engine manufacturers have made them more complicated. They put more things into them, like, GDI engines and turbochargers and all this other stuff in there. And what's happened is the pathway where the oil is going through has gotten smaller and smaller. So what ends up happening is they recommend thinner and thinner oil. So right now, 5W30, 5W20, 0W20, that's probably the heart of almost all American vehicles that are on the road now that are being made, and most European actually are heading in that direction. So we can go next slide. I think we're doing pretty good on time here. So a couple more slides, just some basic information. So another key industry organization is known as the API, the American Petroleum Institute, and they define the tests that are needed to meet the current specification. So as I look over to my screen over here, what that means is there's a number of different tests you have to run to become this certification. The current specification is called SP. It just actually went into effect this year. So you have to pass a number of tests. There's a number of bench tests. There's things like, oil burn off, viscosity, ball rust tests, seal compatibility, filterability. There's a number of different tests, and they're fairly extensive to run, but then you actually have to run fired engine tests, and they're actually run at independent test laboratories, and you run things about like, protecting against deposits, protecting against sludge, protecting against wear. Fuel economy. Now that we have these GDI engines that I mentioned, there's a test that makes sure that the oil is going to operate properly on there. There's actually a new test that's been added related to chain length elongation. So preventing all those things from happening. So if you pass all those tests, you actually can be certified as API. The current specification is SP. And if you meet the fuel economy requirement, that little sun-looking thing over there is called the API Starburst. That would be on it for if you meet all fuel economy requirements. One new grade that just came in, just real quickly on the left side there, is the API Shield. That's only for viscosity grades below a 0W16. So, next slide. And then just to wrap up of like, as I mentioned, as you go in, you look at a bottle of motor oil and you say like, what am I looking for on here? So the key thing I do want to stress is, people always ask, what is the right oil? What's the best oil to use? The best oil to use, honestly, my joke is always like, well, you use Castrol. But the honest answer is you want to use what your owner's manual recommends. Always go by the grade that it recommends. It generally doesn't call out a certain company to use, but you always use the grade, and you can see on the left side there at the bottom, there's an arrow that points to where the grade is. If you're confused where it is too, that API, they call that the API donut. In the center of it would be the grade too. It'll say SAE and the grade. The type of oil would be mentioned somewhere on it. If you look on the top area there, it'll talk about it being synthetic. So they generally don't call out you need to use a synthetic or not. There's not a lot of cars that do call out that. But what you do want to look for is where the product specifications are. So if you look at that list that's there, it mentions API SP, but it also mentions the older specs. They're all backwards readable. If you have a GM car, it's going to call for a Dexos oil. It's on the list there. If you have a Chrysler, again, it lists Chrysler spec here. If it's Ford, it's a Ford spec. All these things are going to be on the label. And then there's that, as I think I neglected to mention it on the previous slide, but there's that API donut. And that's really telling you what the specification is. If you buy a newer car, like as an example, if you buy a Ford right now, it's going to say use an API SP 0W20. If you look at that donut, that's going to tell you all the information. But it also on our labels, you see like the different specifications it meets. So that's a very quick overview on what motor oil is. Hopefully this helped. We'll certainly be here for questions. My counterpart John Demko is with me as well. So after the other presentation from Michelin, we'll be happy to answer any questions that have come up. So, Lindsay, I think that's my last slide. So
thank you, Derek. Thank you for that time. And I know we've got a few questions that have already come in, so we're definitely going to have some questions here at the end. But next, I would like to introduce our next speaker. Tom Carter is joining us from Michelin, and Tom is the Technical Communications Director for Product Marketing. He earned his BS in mechanical engineering in 1981 and then completed his Master's of Science in Mechanical Engineering in 1983 at Virginia Tech. For 32 years, he has practiced engineering with Michelin America's Research Center, mainly in product development. He has been involved in the development of products ranging from large truck tires to European winter tires and performance tires for Acura, BMW, Mercedes, Lexus, and other luxury performance sedans. He was directed the Tweel concept team and the concept phase of the current Michelin product, Cross Climate. So Tom, at this point, I am going to turn it over to you.
Hello, I'm glad to be here. And Ben, I think, is going to start my presentation. We'll move right into that. So I was asked to give you an overview of Tires 101. That's actually quite a long course, 137 slides. So we're not going to do that. So we're going to start with something that's kind of fun. It's a video and it's going to give you an idea of traction. It's going to be on ice, but you can relate this to dry and wet. So go ahead. Got 1 second for technical hurdles. Here we go.
I'm Tom from Michelin with my friend the Michelin Man. Today we're going to learn about what gives a tire good traction. It's easy to look at the tread pattern and think that's what does all the work. But in fact, a lot of the real magic is in the tread compound. I have with me 3 smooth hockey pucks. The only difference between them is this one is made out of a summer tread compound. This one is made out of a typical all-season tread compound. And this last one is made out of a winter tread compound. Let's see how far they slide on the ice. Go ahead, Michelin Man. Give him a push. So what did we just learn? The tread compound with the most traction stopped first, just like the tires on your car. The winter compound stopped first on the ice, followed by the all-season compound, and the summer compound slid the farthest, showing you once again why you don't want to drive summer tires in winter conditions. Michelin designs the tread pattern and the tread compound to help you stop better. Be safe, drive on good tires. Thank you.
Michelin, a better way forward.
Okay, so that's a pretty cool video, in more ways than one, because it gives you an idea of how the tread compound is so important in designing a tire. So I'm going to give you a little bit about normal tread design, as soon as I can get the mouse. And you see with normal tread design, if we're designing a summer tire, we take a summer tread pattern, we take a summer tread rubber, and we combine them together and make a summer tire. Similar practice with a winter tire. With a winter tire, take a winter tread pattern, lots and lots of cuts and grooves. We take soft rubber, that is low TG or low glass transition temperature, and we put those two things together and we'd have a winter tire, very good for winter conditions, not so good for summer conditions, wet and very hot. Now, if we're making an all-season tire, traditionally, we would take a tread pattern that's in between summer and winter. We'd take a tread rubber that's in between the two, and we'd put that together, and we would make a very, very good all-season tire. That is a tire that works pretty well in snow, pretty well in summer. So if Derek hired me to make a multi-grade oil, I would just take some 0 weight and 40 weight and mix them together and have your 0W40 oil. Work out pretty well, huh? So that's how we traditionally do it, but we wanted to take a different approach with our latest product, which is the Cross Climate 2. And it's quite interesting what we did. What we wanted to do is we wanted to ride, if the mouse will work, we wanted to ride the green curve up here, and to do a winter tire, we would ride the tread pattern up to here and have a tire that's very good in winter properties, but not very good in dry and wet. If we wanted to do a summer tire, we'd just go the opposite way. We take a tread pattern that's blocky, doesn't have any cut ups in it, and it'd be good in summer, and we drop the tread rubber on it and make something very good in summer, not good at all in wintertime. And to make a all-season tire, we would meet right here in the middle. Well, we really wanted to be at a better spot than that. We'd really like to have really good dry and wet and good snow. And we realized that, in fact, we could get there. We could actually get to this point right here, but we had to rethink our design. And in order to rethink our design, what we did is we rode this curve up of compound pretty much as far as we could take it towards the snow properties. And then we came back the opposite direction for our summer properties. And those of you that know math and science know that you can actually do that with independent properties. And that put us at a very unique position. That gave us a tire that, in fact, is very good in dry and wet and still very good in snow. In fact, this tire, the Cross Climate 2, is 3 Peak Mountain Snowflake certified, which means it's certified for use in snow climates like Quebec, Canada. So it's a very interesting tire. Now, what does that mean when we talk about how we're actually designing our tire? Well, that means that we took a pattern that was very summer oriented. In fact, that's the pattern we took down there. And we took a tread rubber that was very winter oriented. There are other technologies involved in it, but it's still a tread rubber that is very winter oriented. And we crossed the two. We did not meet in the middle with tread pattern. We did not meet in the middle with tread rubber, but we crossed the technologies, and that gave us a breakthrough all-season tire, which works quite well in all types of weather. For summer, so what are some of the concepts we discussed here in a very short amount of time? Summer tires, winter tires, all-season tires. You've seen a little bit about traction. You've seen how compound affects performance. You've seen how tread design affects performance. And you've seen how we've been able to take these concepts above and come up with a breakthrough tire design. Now that you have that, I'm going to go to a different presentation because you know that you need a good tire to go on your vehicle. You know you need good oil to go on your vehicle. I'm going to give you some clues as to how to pick out a good tire and how you put a tire on your vehicle. And I'm going to do that with a specific example instead of going through all the ins and outs. And that's suppose you have an all-wheel drive vehicle, and there are many all-wheel drive vehicles out there. And in fact, those vehicles have a center differential, which means that the rolling radius, or the rate at which the tires turn at all 4 corners, need to be the same, or you're going to burn out that center differential. So Ben is he's getting there. So he's getting to my, click on it right there because,
Sorry, I jumped in.
there, okay, go back. Go back 1. So we'll go back 1. So you got one tire that's flat. You hit a nail and you flatten that tire and you need to replace that tire. Now, what the heck do you do as a dealer? Well, you don't care unless you're a dealer, but you do care because your dealer's going to advise you. And what do you do as a consumer? And again, you don't want to mismatch tires because you're going to burn out that center differential. So there's a lot of recommendations given by the manufacturers. Some of them say, well, just put the tires on there as long as there's no big difference. Some of them say, okay, no, you got to be in pairs on axle. Some of them say you can be pairs, but on axle, or replace all 4. And there are a lot of manufacturers and dealers that will say you got to replace all 4 tires. So you just ran, I'm sorry, you've only got 5,000 miles on that tire. and it's flat, you got to replace all 4 of them. You're throwing away 3 good tires when you do that. But you don't want to burn out that center differential, that's for sure. So we said, you know, this is not a very good position for the consumer. We want to see what are the physics associated with this. So if I took a quarter out of my pocket and I rolled old George Washington 1 revolution, George would travel exactly the circumference of that quarter. But that's not what happens with a tire. It's a little bit different from that. With the tires are loaded and they're not a circle, they're flat on the bottom. And when you roll a tire, it does not roll that circumference of the tire. It rolls a significant distance shorter. And we say that distance is the rolling radius. Now that distance is not the loaded radius, and it's not the free radius. It's some radius in between. And this is very well, let me explain that a little further. If I took this toy Tonka tractor and I rolled it 1 revolution of those belts, it would travel approximately the length of that belt. That's a good way to think of things with tires, because tires have a belt. And that belt's below the tread. You can see it. It's represented by the red circle on the left and by the red line on the cross section of that tire on the right. So when I roll that tire, it doesn't roll the circumference of that tread. It rolls the circumference of that belt, approximately. So that's a big clue, because as the tread wears down, that belt length does not change. And this is well known because when the manufacturers set their odometer and speedometer, they do not set it to the outside diameter of the tire. They set it to the rolling radius of the tire. So if you were to look up the specs of your tires, you would see there's a revolutions per mile. And that revolutions per mile is very different than the value that you would get if you calculated it from the outside diameter. Because once again, when your tire rolls, it does not roll the length of the exterior circumference. Okay? So this was quite interesting. So we know now that the exterior circumference does not set the rolling radius. So we know that. So I'm going to give you a hypothetical situation. I've driven my Subaru in, and it has these Bridgestones on it, and the diameter is 31.6. And I need to replace it because one's gone flat. And this dealership that I went into, they don't carry Bridgestone. And I got to make a choice. So I think, okay, that Michelin looks like a good tire to go on there because the diameter is exactly the same. But then you recall, that might not work so well. I need to look at the rolling radius. And then you say, oh, well, actually, that Kumho has a better rolling radius. But the dealer says, no, you don't understand, because you've worn off half of that tread depth. So your circumference now, or your diameter now, is 31.1. It's no longer 31.6. So if my supposition is correct, that tread depth at 13 30 seconds versus half worn should have a rolling radius that's pretty close to the belt length, and that belt length shouldn't have changed. So in fact, we measured that rolling radius, or revolutions per mile, and in fact, it is very, very close, even though that diameter is very different. So what does that tell us? Well, it tells us that about that particular tire, but we wanted to know about a whole range of tires and a whole range of brands. So you can see we looked at the Michelin tire, the Goodyear tire, the Kumho tire, the Hankook tire, the Bridgestone tire, and not surprisingly, they all follow the laws of physics, which tell us that that top line there shows the exterior diameter new and worn. The bottom line shows you the rolling radius. The rolling radius does not change significantly with tread depth, which is surprising, but it is true. And it also tells you something else. It tells you that when you pick a tire, you need to pick the same brand and the same tire make, and of course the same size. And that is if you're replacing a single tire on an all-wheel drive vehicle, because you do want to match that rolling radius. Okay, so that is how you want to make that choice. Now, we've gone further. On the right-hand side, we have told people, on the left-hand and the right-hand side, in our Michelin fitment guide, we have told the dealers and the consumer that as long as it's not against the manufacturer's recommendation, you are okay to replace a tire that is virtually half worn with a new tire, even on all-wheel drive vehicles, as long as you have the same manufacturer and the same tire model. You will not burn out your center differential. Now, obviously, we're going out on a pretty big, that's a pretty strong statement, I'll say that. So we worked with SAE and we published a paper cleverly called Tire Rolling Radius Evolution with Tread Depth and the Implications for Tire Replacement on All-Wheel Drive Vehicles. So that is the paper that we published. It's a free download for any of you, and it gives you this information for those of you that have all-wheel drive or recommend for people with all-wheel drive. So when you get a tire, I do want to say that you do have to follow the manufacturer's guidelines, and we recommend, especially if you're replacing one tire, there's all these things that are written on a tire. The thing you really need to understand, pick the right brand, pick the right tire line. We can recommend Cross Climate quite well for you. Pick the right size, which will look something like that, 235/50 R18. And then there's something called the service description. The first number, 97, is the load index, so pick the right load index. And then the letter that follows it is the speed index. So that's how you pick out a tire. So now you know how to design a tire, and now you know how to pick out a tire. So that is a lot of information in 20 minutes. Thank you very much.
Thank you, Tom. Thank you for putting that presentation together, and thank you, Derek, as well. We have gotten some questions in during your presentation, so if you guys are available to stay on for a few more minutes, John and Derek, if you all can make sure you're unmuted and add yourself to video, I'm going to start firing away on behalf of our audience today.
Okay.
So our first question actually comes in from our chief judge for next year's Concours, Paul Inario. And he is a collector of a lot of pre-war cars. So this is specific to something that he's very passionate about. So his question is, given the fact that zinc or ZDDP was removed from oil, people with pre-war cars and certain high performance cars now have a problem of finding a product with the appropriate levels of zinc. What product in Castrol's line would you recommend for these cars with solid lifters?
Well, the current product that we have that has traditional levels of zinc would be our Edge 5W50. That's the one product that we currently offer that has additional zinc that would be aligned with more historic levels of zinc. Now, I think that there may be cases, and I think that additional information should be gathered as far as the specific car that this gentleman wants to lubricate. And they do sell zinc supplements as well that you can add to motor oil to elevate the level of zinc anti-wear if you have a flat cam and tappet system. But the products that the product that we currently have is a 5W50 Edge product, which has a higher level of zinc. Now, the other thing that we advise is if a customer is doing any type of changes to the engine, in particular increasing the valve spring load, which will put more stress on the valve train, there may be some additional zinc that is required. But you really have to take it on a case-by-case basis. You have to determine, whether traditional levels of zinc are acceptable. If that's the case, then Edge 5W50 would meet that. If there have been any type of changes to the engine that might put more load on the valve train, supplement zincs may be required.
And Lindsay, sorry, I couldn't get myself off mute quick enough.
No
Thanks, John,
worries.
for taking that. But if the question comes up, the level of zinc is about 1400, 1500 ppm in the Edge 550 that John mentioned. The reason why it's difficult to use those, why there's not a lot of fluids out there anymore is, when I talked about GF6 and API SP, you have to be at a maximum amount of phosphorus. There's a minimum and a maximum amount of phosphorus level you can have in the oil, and the zinc comes along with the phosphorus. There's something called ZDDP they use. If you have any if you're trying to rate the oil for like a certain specification, you can't go above a certain zinc level. So that's what it leads to that. So,
Okay.
John's right.
Thank you, guys. Next, we've got a question. Again, this is for Castrol from Kenneth Chen, and he is asking what retail stores might he be able to buy Castrol oil that meets Volvo specifications? And the oil he is specifically referencing is Castrol 0W20.
Yeah, well, it's not a technical question, but I can understand why certain products from Castrol may not be at the retail shelf, because it depends upon the overall demand for a particular oil. So in the case of the Volvo, and we do have a product that meets, it's a Volvo specification for 0W20. It's called Edge 0W20V. The only thing that I could say is if the gentleman wants to provide some additional information, an email, we could ask the question of the appropriate people within Castrol as to where this particular product is available. But I can certainly understand that it may not be common at O'Reilly's or AutoZones or Walmart, because they're looking for products that are going to jump off the shelves, and there's only so much shelf space that they have. So it's understandable that may not be easily found at retail.
And Kenneth, just to follow up on that, or if anybody has any questions following this event that didn't get answered today or that you think of after the fact, please feel free to email me. My email address is lharrell, HARRELL, at HHI which is CONCOURS.com. And I'm happy to try and get those answered after the fact as well, as long as Derek, John, and Tom are available to answer. Let me move on to a tire specific question. We have Mary asking, how much further would a summer track DOT tire slide on the ice?
A lot further. So there's a couple reasons you don't want to use a summer tire on ice. The first is you would slide just a tremendous amount further, at least double an all-season tire. And secondly, you run the risk of actually passing through that glass transition temperature, which means the rubber will be brittle like glass, and you will actually crack the rubber.
Well, let me stick on you, Tom. We've got another question here that's tire specific from Michael Dyrenfirth. Are there any ratings for tire noise?
In the United States, Michael, there are not ratings for tire noise. However, in Europe, there are. So it would be possible in some cases for you to find out the rating on noise for certain European tires that are sold both in the United States and in Europe. In general, for the Michelin tire lines, they are adapted for the North American market, and it costs a lot of money to do that rating, that noise rating, and we do not do that noise rating. However, you can look at independent ratings for noise at Consumer Reports, and then subjective ratings at Tire Rack. And both of those will give you a very good idea of how a tire performs for noise.
Okay, one more tire question for you that's come in from Stuart. How do you pick a single replacement tire for a regular two-wheel rear drive car?
I think that's a very good question. The rear is not as sensitive. I would use the same rules, and that is, if you exceed a differential of 5/32, I wouldn't do that. I would replace both tires. However, if it's a relatively new tire, I would choose the exact same make and model. The other thing that I would say about that, it is not as sensitive as the center differential, which is designed to run at the same rolling radius. Your rear differential is designed to run the same rolling radius, but you're constantly turning and constantly changing that rolling radius from left to right, and cars are better adapted at for a different rolling radius left to right than they are front to rear. I hope that makes sense to you.
Wonderful. All right, I'm going to bounce back real quick to John and Derek on some additional motor oil questions. Tom, don't go. I think we've got more tire ones coming in. But Steve Duba is asking, are warm-ups a necessary and good idea with modern multi-viscosity oils? Does this apply to older cars as well?
So with modern, Derek, you want to take it, or you want?
You got it, John.
So with modern engines, which are fuel injected, there really shouldn't be any need to, and auto experts would advise that you shouldn't really have to warm up the car for anything longer than 30 seconds. That's because there's computer controls that can control the fuel oil, the fuel air ratio during the starting process, and there should be no need to, more than 30 seconds is really unnecessary as far as warming up modern fuel injected vehicles. Now, if you go back to older vehicles with carburetors, my goodness, I guess that's back in the 80s. It's been quite some time since they put a carburetor on an engine. But in those particular cases, it is actually was recommended to warm up the vehicle. And the reason for that is that when you start to drive the vehicle, you want the proper fuel air ratio to avoid stalling and improper mixture of the fuel air during the actual driving process. So for older carbureted engines, the general rule of thumb was to warm it up, allow the RPMs to come down, because carbureted engines started very rich in fuel relative to the fuel air ratio, and let that warm up, allow the RPMs to come down, and then drive. But for fuel injected engines, no more than 30 seconds should do the job.
Great. Derek, anything to add?
No, I think John covered that.
Okay, wonderful. One more question. I've actually got two more oil questions for you all before we switch back to Tom. Does the base stock for synthetic oil come from in-ground petroleum?
So synthetic is defined a couple different ways. So when you think synthetic, as I mentioned, there's the different groups of base oil. So when you're thinking of a group 3, that does come from crude oil, and that's refined. It's refined to the point, so simply the definition of refineries are just taking more and more stuff out. So why a synthetic oil, part of the reason it costs so much is because there's a lot more processing that goes into it. It's a lot more, a lot less of the sulfur and the impurities that are in there, a lot of the wax that's taken out of there. So that does come from crude. But then there's also what they call polyalpha olefins, or PAOs. Now those do not come from the ground. So it's sort of a mix. So there's two different, there's different things that can go into motor oil. There could be PAO that goes into motor oil, or there could be group 3 oils. Group 3 comes from the ground. Group 4 polyalpha olefins doesn't come from the ground. The level of protection, that's provided by a group 3, I mean, you're talking, cold low. Some of the benefits of synthetics are, it does very well at low temperatures, much less likely to boil off at high temperatures or volatilize at high temperatures. The difference between a group 3 and a group 4, I mean, really PAOs are for very specific reasons. They're really, you're never going to get down to the cold levels of saying, I have to have a PAO. If you want to have it, that's fine. But so the simple answer to the question is it's sort of a split answer, but the group 3 stuff does come from the ground. The PAO does not.
Great, thank you. And last one on motor oil from Bill Ferrari, which is one of the best names I've heard in a long time. In regards to what current oil to use, what is recommended to use in a classic Mini, as the oil serves for engine lubrication as well as gearbox and differential lubrication? These motors are also a flat tappet design.
Yeah, so not to be cute with the answer, but I'm going to be cute with the answer. The answer is to ensure that the motor oil you're selecting is specifically claiming application for that classic Mini. I mean, it's probably a higher viscosity oil. It's certainly a high zinc oil, I would expect, probably like a 20W50. But the important thing is that this oil has to lubricate not only the engine, but it has to lubricate some of the other systems. And so there are other features of the oil beyond engine oil performance specifications that would need to be validated to ensure that that oil can protect the engine, protect the transmission, the differential, the complete package. So my recommendation would be research oils that specifically are indicating they are for classic Minis, and then follow that course as far as the oil to use.
Okay, great, thank you. And then Tom, if we can ask you a couple final questions for Michelin.
Sure.
Lee Niner is asking, is there a time period in years of when tires should be replaced because of age?
Tire service life is 10 years. So you should not exceed 10 years. Most tires come out long before 10 years for a variety of reasons. The largest reason is wear out. But the recommended industry tire service life is 10 years.
Okay, wonderful. And then final question, again for Michelin. Could you please comment on tire pressure management for individuals participating in track events on Michelin summer sport tires? This was a big concern for a track event at a high bank track, i.e. Daytona Speedway. However, it appears common to make adjustments that deviate from normal highway recommended pressures, even at tracks that are less demanding.
Very good question. So Michelin has a product now available at Tire Rack called Track Connect, which is exactly geared for that situation. And what it does is it recommends pressures for you. You start at a pressure, which is a track pressure. Then as you lap, it will suggest to you, based on a database of software, where you should take your pressures for your driving style, for that track, for that temperature, that day, and your tires to maximize your lap times. So I think that's what you're looking for. Now, in the general sense, there are different setups for tire pressure for tracks if you didn't want to go into that level of detail or purchase that very fine device which works with your smartphone. I am not an expert in that area, so I can't comment to that. However, the track pressures typically are different from your daily driving pressures.
Well, wonderful. Well, I want to thank everyone. I want to thank Tom and John and Derek for being here today. I obviously want to thank Michelin and Castrol for their ongoing partnership with us on the Driving Young America Boulevard. Just a few things to note. We do have a couple of other events still on the schedule for the Driving Young America Boulevard powered by Castrol virtual series. The next one's going to be Sunday, November 1st. It's our Michelin Junior Challenge design, the finalist presentations to our expert panel of judges. Again, those judges that will be joining us, for those who have been with us before, you've heard this list, but for those who are new, We've got Moray Callum from Ford, Ralph Gilles from Fiat Chrysler, Vera Park from Jaguar, Michael Simcoe from GM, Jay Ward from Pixar Animation Studios, and Ed Welburn, who is formerly retired from General Motors as well. So we've got an expert panel. It'll be fun to have the students show their entries, their final entries to these judges. And we've got another event in the works with our friends over at Jaguar Formula E that we're hoping to announce soon as well. So stay tuned for that. But thank you to everyone for your time today. I hope you found it interesting and informative. And again, thank you, John, Tom, and Derek for your time and your presentations. Hope everyone has a fabulous night, and we'll see you at the next event on November 1st. Thank you.
Thank you.
Thanks.